So the topic 4, which is about stoichiometry, and the subtopic today we'll discuss the mole concept. What is a mole number and what is the concept of the mole? Example, if I write this equation that carbon is reacting with oxygen and it gives carbon dioxide. So this is the equation, a chemical equation is given. So what is the mole number? The mole number is a coefficient which is written next to element or compound. So what number is written with carbon? Because if nothing is written, it means it is 1. So what is the mole number of carbon? That is 1. What about the mole number of oxygen? The number which is written before the element or the compound. The coefficient of element or compound is called a mole number. So if nothing is written, it means there is 1. So what is the mole number of oxygen? The mole number of oxygen is 1. And what about the mole number of carbon dioxide? What is written next to before carbon dioxide? If nothing is written, it means there is 1. So how many moles are there according to the equation? We'll have the moles of carbon dioxide, that is equals to 1. So basically the mole or the mole number represented by the coefficient next to the element or compound. Another example, if I say H2 plus O2 gives 2H2O. So this is the equation written, 2H2 plus O2 gives 2H2O. So what is the mole number or how many moles of hydrogen are there? What is the number of moles or how many moles of hydrogen are there? So how we can identify the number which is written before the element or compound? That is called a mole number. So which number is written before hydrogen? 2 is written. So how many moles of hydrogen are there? In this example, there are 2 moles of hydrogen. How many moles of oxygen are there? So if nothing is written, it means what is there? 1 is there. So how many moles of oxygen? 1. And how many moles of water are there? H2O is the formula. So number before that is called a mole number. So how many moles of water are there? There are 2 moles of water. So in the second equation, there are 2 moles of hydrogen, 1 mole of oxygen, and 2 moles of water molecules are there. So basically the number of the molecules or number of atoms involved in the chemical reaction is also known as the mole number. So simple definition of a mole number, it is the number of atoms or molecules which are involved in the chemical reaction. Is it clear? The idea of the mole number? So another example, if I say we have equation calcium oxide is reacting with hydrochloric acid, it gives calcium chloride plus water. So if I say how many moles of calcium oxide are there? In this example, how many moles of calcium oxide are used here? So the number which is written, because nothing is written, it means 1. So it means we have 1 mole of calcium oxide. Then how many moles of HCl are there, hydrochloric acid, in this example? So the number of the molecule or atom here which are used in chemical equation also known as a mole number. So 2 moles of HCl. Then how many moles of calcium chloride are used in the equation? So if nothing is written, it means 1 is there. So total number of moles of calcium chloride according to equation, that's 1. And how many moles of water are there? Number of moles of H2O. That's also 1. So this is the mole number. So the number of atoms or molecules involved in a chemical reaction is also known as the mole number. Now, if we want to find the mole, when we are finding moles, there are two ways to find moles. Number one, you can use the ratio. And number two, you can use a formula, because there are formulas to calculate the moles as well. So there are two ways to calculate moles. Number one is by ratio. Either you can use a ratio or you can use a formula. Now, how we will use ratio to find moles? So it's same in mathematics as you used to work out the ratio and proportion. Like example, if this was the equation, H2, 2H2 plus O2 gives 2H2O. And the question was, find moles of oxygen reacted with 5 moles of hydrogen. So that is the question. We have to find moles of oxygen that are reacting with 5 moles of hydrogen. So you will make two columns. On the left hand side, what is given to you, and on the right hand side, what is required. I'm writing in short REQ, it means required. So what is given to us? If you read the question, they mention find moles of oxygen. So we have to find the moles of oxygen. So oxygen is required. And what is given to us? 5 moles of hydrogen are given. So given to us is hydrogen. So according to the column, when you make two columns, one left hand side, what is given to you, and the right hand side, what is required. So given to us, hydrogen moles are given, and required, oxygen. Now we will use this equation. According to equation, how many moles of hydrogen are there? According to equation. So according to equation, there are 2 moles of hydrogen. And according to equation, how many moles of oxygen are there? 1. So the ratio between hydrogen and oxygen is 2:1. It means, like, if we have 2 moles of hydrogen, we should have 1 mole of oxygen according to equation. But in the question, we have 5 moles of hydrogen, and how many moles of oxygen are there? X. We don't know. Is it clear till now, this point? Then I'll solve the last part. But first thing, you should be able to identify, according to question, hydrogen is given and oxygen is required. And when we check, like 2 moles of hydrogen are reacting with 1 mole of oxygen. So ratio between hydrogen and oxygen is 2:1. So if 2:1 is the ratio, but in the question, we have 5 moles. So if we have 5 moles, how many moles of oxygen should be there? X. And now cross multiply, because in a ratio, how we solve? We cross multiply. So this 2 is multiplied with X and 5 is multiplied with 1. So when 2 multiplied by x, it will be equal to 2x. And 5 multiplied by 1, that's equal to 5. So if we want x, so x will be equal to 5 divided by 2, which is equals to 2.5 moles. So how many moles of oxygen will be there if we have 5 moles of hydrogen? So it will be 2.5 moles of oxygen. Is it clear, this example? How we use the ratio? I'll give another example, but in this one, how we use the ratio to find the moles. There's another example. So whenever you are using a ratio, equation will be given. So you have to use that equation to work out the ratio. Look, the equation is given that 2 moles of hydrogen reacted with 1 mole of oxygen, and it is giving 2 water molecules. The question was, find moles of oxygen needed to react with 5 moles of hydrogen. So according to equation, if we have 2 moles of hydrogen, when you make 2 columns, you have hydrogen and oxygen. According to equation, when you see the equation, if there are 2 moles of hydrogen, how many moles of oxygen should be there? 1. So ratio between them is 2 is to 1. But in the question, you have 5 moles of hydrogen. So if we have 5 moles of hydrogen, how many moles of oxygen will be there? X. And then how to solve the ratios? You just cross multiply. So this 2 is multiplied with x and 5 is multiplied with 1. So it will be 2x is equals to 5, and 2 is multiplied with x. So other side it will be divided. So it will be 5 divided by 2. So how many moles? What will be the value of x? So the value of x will be 2.5. So simple ratio we can use to work out the moles of unknown substance from the given one. Is it clear, Abdullah Sarfraz? Another example, N2 plus 3H2 gives 2NH3. And the question is, find moles of NH3 or ammonia produced by 7 moles of hydrogen. So what we do, we'll make 2 columns, and on the left hand side what is given to us, and on the right hand side what we are finding or what is required. What is given to us in this question? Which substance is given? This is a question, and this is the equation which is given. Which substance is given according to the question? Find moles of NH3 produced by 7 moles of hydrogen. So which substance is given to us? So hydrogen is given, or H2 is given. There are 7 moles of hydrogen. So hydrogen is 7 and NH3 we are finding. Even you can write like 7 moles are given and we are finding, so it is X. You can write like this. Then what is the ratio between hydrogen and NH3? How many, according to equation, how many moles of hydrogen should be there? 3. And how many moles of NH3 will be there? Should be there? 2. So again we cross multiply. So 7 will be multiplied by 2. When 7 is multiplied by 2, that's 14. Equal to 3 is multiplied by x. So if anything multiplied by x, it will be 3x. And if 3 is multiplied other side, it will divide. So it will be 14 divided by 3 is equals to x. And 14 divided by 3, that's equal to 4.66 moles. So what is the value of x here? The value of x will be equal to 4.66. Is it clear? This example, finding the moles by using the ratio. Anyone having a doubt in this example? Another, if we have say calcium carbonate decomposed to calcium oxide and carbon dioxide. So find moles of calcium carbonate which produce 3.5 moles of carbon dioxide. So we have to find the moles of calcium carbonate which produce 3.5 moles of carbon dioxide. So given and required, what is given to us? Which substance is given in this example? Carbon dioxide is given. And how many moles are there? 3.5. In the question, we need moles of calcium carbonate. Find the moles of calcium carbonate which produce 3.5 moles of carbon dioxide. So according to equation, if we have 1 mole of calcium carbonate, it will produce 1 mole of carbon dioxide. So we need moles of calcium carbonate. So CaCO3 is needed and moles of carbon dioxide are given. So calcium carbonate is unknown x and carbon dioxide is 3.5. But according to equation, when you check the equation, according to equation, if there is 1 mole of calcium carbonate, it will produce 1 mole of carbon dioxide. So ratio between carbon dioxide and calcium carbonate is 1:1. So just cross multiply. So when you cross multiply, 1 multiplied by x is x and 3.5 multiplied by 1, so that is also 3.5. So what it shows, as it is clear, as you can see from the equation, if we have 1 mole of calcium carbonate, it will produce 1 mole of carbon dioxide. So if we have 3.5 moles of carbon dioxide, how many moles of calcium carbonate will be there? The same number of moles of calcium carbonate will be there. So equation is always given for the simplest ratio, and we use the ratio according to the values given to us. Is it clear? Yes, Abdullah. You have any doubt? Heather? Yeah, the answer is 3.5. Heather, Abdullah Khan, any doubt? So this example, I want everyone to solve and state your answer in a chat. So the equation is H2 plus O2 gives H2O2. This is a compound known as hydrogen peroxide. And the question is, find moles of H2O2 produced by 5.5 moles of hydrogen. So we have to find the moles of H2O2 which are produced by 5 moles of hydrogen. So we'll use the ratio given and required. Solve this and state your answer in a chat. The mole number is a number which is written before the element or compound in the equation. Yeah, H2 is given and H2O2 is required. Because we want to find 5.5 moles of H2. We have 5.5 moles of H2 and we want to find the moles of H2O2. So this will be 5.5. Yeah, that's true. 5.5 and hydrogen peroxide is unknown. But when you check the equation, the simplest ratio, if we have one molecule of hydrogen, we should have, if we have 1 mole of hydrogen, we should have 1 mole of hydrogen peroxide. So ratio is 1:1. So if we have 5.5, then how much should be their X? And how to solve? Cross multiply. So 1 multiplied by X, that is X. And 1 multiplied by 5.5, so it will be 5.5. Is it clear, this example? To everyone? Another example, the equation is Fe2O3 plus 3CO gives 2Fe plus 3CO2. That's the equation. The first part, find moles of CO reacted with 5 moles of Fe. That's the first part. Find moles of CO reacted with 5 moles of Fe. So how to solve this question? What is given to us and what is required? What is given in the first part? So CO is given or Fe is given? We have to find moles of CO which reacted with 5 moles of Fe. So iron or Fe is given and CO is required. Now when you check how many moles are given, 5 moles are given, and how many moles of CO are there or carbon monoxide, that is X, we don't know. But when you check the equation, according to equation, what is the simplest ratio between, or this should be Fe2O3 because in the equation I use Fe2O3. So 5 moles of Fe2O3 are there. So the simplest ratio between Fe2O3 and carbon monoxide, that is 1:3. So 5:X because we have 5 moles of Fe2O3 and we need moles of carbon monoxide, so 5:X. And according to equation, if we have 1 mole of Fe2O3, we should get 3 moles of carbon monoxide. So simplest ratio is 1 is to 3. Now cross multiply. If 1 is multiplied by x, that is equals to x, and 3 is multiplied by 5. So 3 multiplied by 5, what we will get? We will get 15 moles of CO. Is it clear? The first part. Because the ratio of the moles is 1 is to 5. 1 mole of iron oxide, iron 3 oxide, react with 3 moles of carbon monoxide. And in the question, we have 5 moles of carbon, iron 2 oxide, iron 3 oxide. So we'll get x moles of carbon monoxide. So cross multiply. 3 multiplied by 5, that's 15, and 1 multiplied by x, that is x. So it will be x into 1 is equals to 3 into 5. So when we simplify, x will come out as 15. Now the second part, normally when the parts are interrelated, if they say find moles of Fe produced, so that's only a simple part, but the parts are interrelated. They're asking find moles of Fe produced. So actually this second part is related to the first part. So in the first part, how many moles of Fe2O3 were given? 5 moles were given. So we have to use the same 5 moles, like we have Fe2O3 and Fe. What is the ratio in terms of equation? If 1 mole of Fe2O3 is there, then how many moles of Fe should be there? 2. But in the question, if we have 5 moles, then how many moles should be there? X. So whenever you're solving the parts in the moles, these parts are interrelated. So even in part B, nothing, they're asking for the moles of Fe, and they did not give anything. So if they did not provide you any information, it means you have to use information from the previous part. So in the previous part, the given was iron oxide. So you are using that iron oxide to get the moles of iron. So if the 5 moles of iron oxide were there, x moles of iron, and according to equation 1 is to 2 is the ratio. So we cross multiply. 5 will be multiplied with 2, that's make 10, and 1 will be multiplied by x, so it will be x. So how many moles of iron will be produced? It will produce 10 moles of iron. Is it clear, the second part? So even though in the second part they did not provide you complete information, but you have to use information from the first part, that what is given in the first part, you have to use that to solve the other part. So example, the second part is just find the moles of Fe produced, and nothing is given. And when you are solving the moles, you use the ratio of between the given and the required. So we have to find moles of Fe, so Fe is required. But what is given? In part B, nothing is given, but for that you have to check part A. So what was given in part A? In part A, they give 5 moles of Fe2O3. So you have to use the same values here, that the given was Fe2 and O3. So if 5 moles of Fe2O3, then X moles of Fe will be there. And according to equation, when you check the equation, if 1 mole of Fe2O3, how many moles of Fe will be there, or iron will be there? That's 2. So the ratio is 1 is to 2. And when you cross multiply, 5 will be multiplied by 2, that's make 10. And 1 will be multiplied by x, so that is x. So the total number of moles will be 10. Is it clear? So in the moles question, the parts are always interrelated. I'll give another example. You have equation H2 plus Cl2 gives 2HCl. And the first part of the question, find moles of Cl2 reacted with 7 moles of H2. So we want to find the moles of Cl2 from 7 moles of H2. What is given and what is required? Yeah, what is given to us in this example? 7 moles of H2. So hydrogen is given to us. And what is required? We need Cl2. And according to question, 7 moles of H2 are given and we required X moles of chlorine. So this is according to the question, but according to equation, if we have 1 mole of hydrogen, that will react with 1 mole of a chlorine. So the ratio between them is 1:1. So you cross multiply, 7 will be multiplied by 1, that's 7. And 1 is multiplied by X, so that is X. So what is the answer? You will get the 7 moles of chlorine. That is the first part. In the second part, if you have to find the moles of HCl produced. So in the second part, you need the moles of HCl produced and the information is not complete. They did not mention from which substance. So required is HCl, but what is given to us? So again, we have to check the first part, what was given to us. Given to us was 7 moles of H2. So if 7 moles of H2 were given, how many moles of HCl will be there? X. And according to equation, if there is 1 mole of H2, how many moles of HCl should be there? 2. So the ratio is 1:2. But we have 7 moles. How many moles of HCl should be there? X. We cross multiply. So 7 is multiplied by 2. That's 14. So 1 is multiplied by X and 7 multiplied by 2. So how many moles of HCl we'll get? We'll get 14 moles of HCl because the ratio is 1:2. If 1 mole is reacting with 2 moles, so if there are 7 moles, or if 1 mole is producing 2 moles, so if we have 7 moles, it will produce 14 moles of the product. Is it clear, this example? The second example. To everyone. So whenever a question is given related to moles, there are 2 ways to solve this. The first method is by using a ratio. So we did, if ratio, if you want to solve the question related to ratio, we'll use the equation and we'll get the final result. The second way of finding the moles is by formula. So you can find moles by using the ratio, or you can use the formula to find the moles. And there are 3 formulas which you have to learn or memorize. These are the three formulas of the moles which you have to learn or memorize. Number one, the number of the moles equal mass in gram divided by molar mass or molecular mass. How to use the formula that we will discuss, but first thing you have to memorize. The second formula, if you need moles, that is concentration multiplied by volume. And the third formula for moles is the volume divided by 24. So these are the three formulas, number 1, 2 and 3. And how you will learn, you can learn from this triangle as well, where n is representing the mole. So if I need the moles, that is equals to mass in gram divided by molar mass. Molar mass means atomic mass or molecular mass. If I need moles, it can be concentration into volume. And if I need moles, it is volume divided by 24. How to use these formulas, I will discuss each formula and give example for each formula. So you have to learn and memorize these. So you have to learn and memorize these formulas. I will share another link and continue this discussion, how to use and memorize these formulas.